So read this question. In this question, if the potential in a region is expressed, it is given by 6xy minus y plus 2yz, right? This is the potential as a function of x, y, z is given. Now you have to find the electric field at point 1 comma 1 comma 0, right? So to find the electric field over here, what you have to do, the electric field is nothing but the x component plus y component plus z component, right? So to find the x component, right, you have to differentiate, or you have to take the partial derivative of potential with respect to x such that y and z are constant, right? So if you differentiate, right, with respect to, this is called the partial derivative of v with respect to x, 6xy minus y plus 2yz, right? So yz is constant, this is constant, this is constant, so its differentiation is 0, and y is constant, only the x is variable, so the differentiation of x is 1, so it is 6 into 1 into y, right? So this is the 6y plus, and this is the minus, so the x component, the ex component is nothing but 6y. In the same way, to find the y component, you have to differentiate, you have to take the partial derivative of v with respect to y such that x and z are constant. So therefore partial derivative of v with respect to y, what is the value of the v? It is 6xy minus y plus 2yz. Here only y is the variable and all other constant, so it is equal to what? Minus y differentiation is 1, so it becomes 6x, y differentiation is minus 1, so y differentiation is 1, and 2 into z is constant, plus 2 into z, right? So this is the ey component, right? Now if in the same way the ez component you can take, you can find partial derivative of v with respect to z such that x and y are constant, so minus del upon del z is right, differentiation of 6xy minus y plus 2yz. Look, here the x and y are constant, so this is xy constant, 6 is constant, so its differentiation is what? 0. The y is constant, its differentiation is also 0, so this is the minus sign. 0 plus 0, the differentiation of z is 1, and 2y is constant, so plus 2y, so it is equal to minus 2y, right? Now we have to find the electric field where at 1 comma 1 comma 0, it means x, y, z, right? So the electric field x at 1 comma 1 comma 0, right, 1 comma 1 comma 0, so x is 1, y is 1, so minus 6 into 1 is equal to minus 6. This is the x component. The y component at what point? 1 comma 1 comma 0, so in place of x, this is the minus, you will put 1, it is minus 1, 2 into z, right, 2 into z, z value is 0, so you have to put the x, y, z value here, and then you will get minus 6, 6 minus 1, it is equal to minus 5, right? In the same way the ez is what? At 1 comma 1 comma 0, right, this is what? It is minus 2 into y, minus 2 into y, y value is what? Say 1 is equal to minus 2. So this is the ex, ey and ez component. So therefore the electric field is nothing but ex I cap, ey z, ez j cap. So ex is what? Minus 6 I cap, right, minus 5 j cap, right, and minus 2 k cap. Newton per coulomb is the electrostatic field, right? So which option is the correct option? Can you check? If you take the minus common, 6i plus 5j plus 2k cap, Newton per coulomb, right? So which option is matching? So third option is the correct option. Okay, so in this way you can find the electric field, right, using the partial derivative of potential with respect to x, y, z component, right? If you want to watch all this type of the video lecture in English, especially for South student, you can subscribe our channel. And so if you want to join our Telegram and the WhatsApp group, you can join through the link given in the description, right? All the best.